Hi, I'm Sölvi, a simulation specialist here at Treble, and I'm going to give you a deeper dive into the scene generation tools that we've been developing and are releasing now as a beta. And what I'm going to show you today in this tutorial is how basically to load your input data, and on the one hand how you can build kind of very carefully craft scenes manually, how they sound and how you can kind of extract very specific parts of the scenes, and then in the end I'll show you what is kind of the main feature, which is kind of how you can generate these scenes very easily in bulk. Those audio scenes, they work in a lazy way, that they are all, while you work with them, they're very lean. You can create new scenes very fast, and then in the end you can kind of transfer something pretty lean to your colleague who wants to use those scenes, and only when you actually need the heavy files, the audio, those get downloaded. Here's a little flowchart of how everything works at a high level. You can define kind of some rules of how to make up conversations. There's an audio collection, which is basically a data set of conversations, of kind of utterances with kind of speaker IDs, different speakers saying different things, and then ideally those should be kind of clipped up into smaller pieces so you can create kind of a natural conversation. These things go into a track generator, which is assigned to a source group, and from some different rules and an IR collection we can create a scene generator, which can either generate just one scene or can create a bulk scene which in the end outputs a scene collection which you can save. So here we have a way to prepare the input data. You can come in with your own IR collections or something from a colleague, something you simulated, or if you are not really interested in simulating, you can for example, we're here just getting a dataset that is available for all Treble subscribers called the Treble10. Here I'm just basically getting that particular one and plotting one example of a simulation. This is kind of a typical part of this dataset. There are lots of receivers in a grid and then 5 sources in the room. On this IR collections, you can do all sorts of things to kind of separate which source or which IR corresponds to what. And in this case, I'm going to take whatever source has a set coordinate higher than 1.9 meters and assume that this is a noise source. So I add a column to my IR collections which tells me if the source is a noise source or not. So this has mostly 2 building blocks. There's the impulse responses, and then there's the clean audio. Here we have crafted a dataset for you using the LibreSpeech open dataset, and we have kind of split it into smaller utterances, which helps make much more natural conversations. So I'm gonna load this. We upload this to Hugging Face, and you can. It's public, so you can download this as well. And at the same time, we're also using like a little noise dataset, which we use as our HVAC system. And then what the scene generator does is it takes this kind of clean audio samples which don't have any room response involved in them, and it kind of contextualizes them or gives them some sort of spatial awareness. First, I'm going to do the manual one, where I start by creating a track generator, and this track generator takes in a dataset of audio blocks. It takes in some rules, which can be, for example, conversation rules if you want to build conversations, and those conversation rules can be like how long each sample lasts, how much it changes, how high which individual speaker is speaking, how much overlap there is in the conversation, and so on and so forth, and then how long the entire thing is supposed to be. Here, for example, I am creating a track generator which uses the speech dataset from Hugging Face that I showed before, and generates two tracks. Here you can see, then we can plot these audio tracks. See, there's like a conversation happening here with like moderate overlap, you can say. Like this is from 0.2 to 0.5, and what you can see here is kind of the free-foot level of each block and the transcript. And then I want to create an actual scene, and a scene is something that is always contextual to a single receiver. So a single receiver, and it can have however many sources are available. For example, here I'm going to get one receiver from the IR collection, and you can see that this receiver has response from 5 different sources. So what I'm going to do is I'm going to start assigning tracks to the sources. I already created 2 tracks here, and I can assign them to sources. I'm doing this manually right now. And then we have something different which is more helpful for these kind of noise sources, like the HVAC system is this repeated audio track which takes the noise sample and kind of sticks them together, fades them in and out in a nice way. And you can assign such a track also to an IR. And as I say, each scene is contextual to a listener, so we can define a few different things for the listener. In this case, we're using a KeyMar mannequin that is available in our device library, and we assign some sort of noise track to the individual channels on the KeyMar, which is like the 2 ears. So we are putting like pink noise at this as 40 dB SPL level to both ears. And then we can define this scene listener, which gives you the receiver, the device itself, orientation of the device, the noise definition that we created here, and then you can assign some list of filters. I'll do this now. Now that I have basically everything for a single scene, I can create this and we can visualize the scene. We haven't rendered any audio, so nothing will play yet, but what you can see in this plot here is like whenever a source is active, the halo around it is kind of expanding and contracting. Like the HVAC is always on, and then this person's talking, this person's talking, this one as well, both talking, one talking, and so on and so forth. And then what we can do is we can take this track and we can render the actual audio. And what this does is start to download the device information, the impulse responses, and everything. So this can sometimes take a bit of time. So I'm going to do this now. Okay, everything is ready, and you can see one of the output waveforms of the different channels. You can check the frequency response, spectrogram, and all sorts of analysis like this, and then you can also, of course, write it to a file. Often in training pipelines, the network needs to know specific things. It needs to extract a fully clean thing from something very noisy or something like that. So the scene generator, the scene features that we have here, they can render different targets, if you will. For example, we can render from a specific track or a specific source. We can render that particular one to get basically only the clean, completely unprocessed thing. We can have it convolved with a full room IR, which is the scene essentially for this particular one, or we can kind of window that particular thing to kind of around the direct sound, so it can either only contain the direct sound or it can contain the first few reflections or whatever. The window length is configurable, and you can do the same thing for the device itself. For example, here I'm gonna get the fully dry signal from a particular speaker, and I can play this.
You left him in a chair, you say? Which chair? Yes, there are. Did anyone know that these proofs
Or
would
I
be
can kind of make it windowed around the first reflections, and I can play that.
You left him in a chair, you say? Which chair? Yes, there are. Did anyone know
This
that these
obviously sounds
proofs
a
would
bit
be there?
different because it included the room, a part of the room response. An important part of this whole thing is that you can create a scene. The scene has all sorts of information. There's the transcript, there's the speakers, information on the speakers, there's the room, the context of the whole room, the source type, receiver type, device type, all sorts of things. And a nice thing about the scenes that you generate with Treble is that they by default and automatically include all the relevant metadata. You can quickly show here a big JSON with some metadata. Here you can see, for example, the transcript, how long this particular set is, speaker ID, things like that. And at the same time, we can also kind of get like a full transcript for a particular target. So here you can see this, very kind of somewhat weird utterances, but this is what you get with the LibriSpeech dataset. It's quite fun, actually. And yeah, so this was a single scene, but as I said in the beginning, the main feature we're building here is for this kind of bulk generation, where you can, with not that many lines of code, you can create hundreds or thousands of varied scenes based on some rules. Of course, your dry audio, and then the IR collections. And the process has these three parts. You define source groups. You can have, for example, you can define a source group which is close to the receiver and might be your targets. Those are kind of conversational sources. And then if you have something further away, this might be some sort of random kind of cocktail party effect, for example. Then you can, as we did before, you can have noise sources in different settings and all sorts of things like this. And this is something you can do very easily by using these kind of polars, filters, expressions on your IR collection. I'll show you how to do this. You can define some rules for the listener, similar to how we did just for the single thing before. And then the scene generator basically takes the information you created and just makes as many scenes as you ask it to make, and does that quite fast. So as an example, I'll start by creating some scene rules, and then add basically source groups to these rules for the scene. I'm going to have two source groups: the conversation one, which has 3 speech sources and is using specific conversation rules. These conversation rules come with a few presets that have like kind of different levels of overlap and a few different things. And then we're going to use a noise group. So first I define the scene. I want the scene to have a duration of 20 seconds. I create a track generator that uses the speech dataset, and the rules will be from presets, and this will be like sequential talkers with increased overlap. So there's quite a lot of overlap and some minor in-track level range in dB, which means that in some cases someone is speaking kind of not that loud, and then it can speak a bit higher a bit later. And then I create the source group. This source group then has this particular track generator assigned to it, and this source group gets assigned to whatever line, or like gets IRs from whatever row in the IR collection which basically has this as a false, so whatever is not a noise source is gonna be relevant for this group. We wanted to get 3 sources, and at minimum we want 3 sources. These can of course be different, so if you want 7 sources but only 4 are available, then this kind of controls. If you would put this to 4, then it's a valid scene. If not, then it's not a valid scene. And you can define group tags. So this is for my training. This is the target that I want. I want to be able to pick up this conversation. And the priority on IR collections is that is basically which source group is the first one to get its pick of IRs. So when I'm creating a scene, then this source group is the first one because it has has a high priority. This is the first one that goes and sees what IRs do I have available. If it finds 3, it's happy, and then it moves on to the next source group. Which brings me to the noise source group. I create a track generator similar way as before, where I get these noise source rules. There's the level dB range, and then there's the reuse single sample, which means that I can, it doesn't matter if I've used the sample before. And then I create these 2 source groups. This one has a lower priority, so because this one gets picked first and this one next. So now I created my source groups. Importantly, there are all sorts of variables that you can control in the source group. For example, this start time in seconds, which if you want, for example, a very specific sound event, you can make it happen after a specific time, and then you use this, and other things. You can see it in the documentation. So now we have kind of rules on the sources and how to create conversations. Now we need some rules on the listener. And as before, we create some device specs. Here we create noise rules, and we have some kind of helper tools to do this. Here we're creating something with a MEMS noise profile, and then again these filter chain. And then from the scenes we set the listener to have these listener rules. The device has these specs, and the orientation can be it can be looking any way around and slightly up and down, basically. And then it's basically as simple as this. We have now created a few rules, and we have an IR collection. And now basically only by putting these few rules out, we wanted to generate at maximum 100 scenes. We define the scene generator with this IR collection and the scene rules, and ask it to generate these scenes. So it starts generating scenes. It's generating about 10 scenes per second. You can see how many it tried to create, how many it actually created. If there would be a non-valid scene, for example, then there would be more attempts than it actually generated. And then this outputs a scene collection, which is a similar concept to an IR collection. It's basically like it's built around a data frame that has all the relevant information about each scene. And we can take each row in a scene collection is an audio scene. And here we can just take a single one and plot it. You can see that it's similar room, if not the same as before. It has this is the listener. The listener is looking out the door, and then we have a few sources. This source 3 is the background or the noise source, and then these are the conversational sources. So we can render this audio. It takes a bit of time, and then as we render the audio, we can play the thing.
The greeting of the apostle is refreshing.
To know how to do
Muhammad also speaks highly
but she
of Christ.
seems like a child.
He never loses sight of the purpose of
Horizon
his
seems
epistle.
extremely distant.
The world brands this a
Mr.
pernicious
Popovic
doctrine.
exaggerated
Time to time,
nothing.
a fleecy tuft of mist.
And a good job
So
for
the
her,
minister of
too.
Christ should exalt his office,
and how odd the directions will look.
So to summarize, what we went through in this notebook are kind of the two main workflows of the audio scene generation. One of them to basically manually create a scene where you can have full control over every component, and this is very useful to get an idea of what you want, which parameters are what you actually want, create some carefully crafted scenes, and then from that get some idea of what can be the rules for the bulk scene generation, which is in a way kind of the main feature, that you can in bulk and very rapidly you can generate tens, hundreds, thousands of scenes from an IR collection only by defining just a few rules on the sources and a few rules on the listener. And importantly, this all comes with or all generates something very lightweight. So it's not process heavy, it's not memory heavy at all. This only creates a recipe for those scenes, and then you can render them later. We're releasing this as a beta feature, but what is to come is that we integrate, for example, the moving receiver or the moving sources into this, so that you can have kind of dynamic positions of your listener or of some sources, and at the same time this dynamic orientation where during whatever conversation the listener can be looking in different ways. So for example, it can't be always looking at whatever talker is speaking, or it can be looking at the noise source because it's a bit bored, or whatever you can think of. This is coming later. It's not a part of the release now, but what is in this particular tutorial is all fully functional, and you can start playing around with it, and we're very happy to receive any sort of feedback from you. So thank you.